Are you searching for smarter ways to generate code with GPT? Or perhaps you're a video content creator aiming to streamline your post-recording process. Welcome to part 2 in building FliVideo, a video asset management tool to accelerate post-recording workflows and automations like speech-to-text, lower thirds and B-roll generation using DALL-E 3. In this video, I used Doc Writer GPT to write the technical specifications and explain the application structure. I will also introduce the GPT programming language that I use for software development and discuss 2 AI agents that improve component creation and pair programming. Today, I'm looking to start building FliVideo. This will be a YouTube automation tool that I need because I use eCamm Live or products like OBS to record my videos, and I need a way to organize and categorize every video that I create. When I did my research into tools that might solve the problem for me, I came across these terms, one called DAM, which is Digital Asset Management, and it's used for people that create social media content, and the other is VAM, or Video Asset Management. Now, a lot of the software products that I found out there were really for bigger organizations, they were for teams, and I'm just a small YouTube creator that just needs to organize the videos that I create on a daily basis. Now I'm looking to build an application called FliVideo, and what it does is it streamlines the post-recording process by providing automatic structure, naming and tagging of video recordings a few seconds after they've been recorded. The application is designed for video asset management and automatically relocates eCamm Live and potentially OBS recordings into a specific project folder and the organization of files, of naming them, of tagging them. Each video handled by FliVideo will be for a project that's either a single YouTube video or an episode in a multi-video podcast. This application will support chapter-based recordings made from multiple video takes in a sequence. This approach will facilitate easy editing, content replacement, and better content flow, which should dramatically reduce the video editing process. Advanced features will include trash and undo functions for any bad takes. There'll be speech-to-text capabilities for transcriptions and text transforming using GPTs. What this should allow me to do are lower thirds, creating teleprompting scripts, or even creating B-roll using DALL-E 3. I'm designing FliVideo to manage and organize content for 4 different forms that I use. They're the long-form videos on YouTube, the episodes within a podcast, the broken down segments that might be in a course on Udemy or Skillshare, and finally YouTube Shorts. And YouTube Shorts are made up of either shorts that are created from scratch or shorts that are extracted from other long-form content. Let's have a look at the GPT I created for the technical design document. Now here is a GPT called Doc Writer. It's a technical writer for software development, and there's a bunch of starting commands such as adding to the technical documentation. It says add a new authentication method or show the current technical design. Let's have a look at how I constructed this bot. I created this technical design document prompt with 5 concepts. There's the role of the bot, that it's an application technical design writer. There's an overview. It's going to help me to create technical design documents. It has a background in software development and system architecture. It also understands concepts like clean code. The main guidelines is that it can help build out the various parts of a technical document when building an application. There are things like the overview, the architecture and the design patterns, a list of features or user stories, and a bunch of other stuff like performance, caching, deployment. I've set up a bunch of commands. I have my dot command, which will allow me to add a new concept to the technical design. We've got the design command, which will give me the complete design in markdown format, and we've got the tell command, which will just give me a little bit more information about any concept in the technical document. Lastly, there's a status, which just gives me a hint as to what commands are available, and help that'll tell me everything about this particular bot. The last area being the response is how should it respond to each of these commands. The dot command should just give me a brief description and no more extra insight from the bot. The design should give it to me in markdown format. I take all this information and I just copy it directly into this bot here. It comes up with a pretty good setup already. Sometimes I'll change the conversation starters. In fact, I usually don't like to have them at all because there's usually enough information right here with my commands to tell me what I need to do. You can see here that when I just typed help, I got a list of all the commands that are available to me. The other thing I sometimes do is when I go to the instructions, these have been generated based off my original information, but sometimes I believe my original information is better than what ChatGPT will do, so I might just select all of it and paste in the exact prompt that I handcrafted. If you want to see the technical design that I created with that bot, you can just go over to the Git repository for FliVideo, and down in it is a technical design. There's a feature list. There's a list of user stories and usage. And a lot of it has been generated using the technical design document GPT. If you want to see a detailed breakdown of the technical design GPT, then let me know in the comments below. The application will be called FliVideo. It's a command line tool. I'll run it and it should watch for any recording changes and then take certain actions. The main things that the command line tool will do is that it will run actions, and in the future I'll probably have some sort of REST-based web server that I'll build into the application so that I can call it from a web browser. To start off with, it will be a library, not an application. I'm going to use a Ruby gem with semantic versioning, and I'm going to publish it to Ruby gems, so if you want to download it, you can look for it there. The structure will also include unit tests. I tend to follow test-driven development. I also want to make sure that every time I change a file, it will automatically run both unit tests and a linter to make sure that the quality of the code is good. Now, this structure will also support integration tests so that while I'm still developing the application, I can start using it by pointing it towards the video that, say, you're watching right now. You can find the project here at clueless.io FliVideo. So we have here a starting project, FliVideo Video Asset Management for Content Creators. We're currently up to version 1 in the semantic releases. If we have a look at Ruby gems, I've just added a new gem to the bottom of my list called FliVideo. It's now at version 1. And the main thing to look at here is that there's an application started up. We've got some descriptions. There's access to the technical specification that I'm building, the feature list, and in the future there'll also be some user stories and usage examples. Currently, unit tests are running correctly. Publishing has happened and also linting is in place. Let's also look at it in GitHub using the built-in Visual Studio editor. I've essentially got a basic structure. We'll explore the docs a bit later where I've built up the feature list and the technical specification. We'll also build some new ideas like the user stories and the usage examples. The library itself is very small. There's nothing going on it at the moment other than a basic command line interface. Very soon we'll develop a couple of scripts that I use to make my code available to ChatGPT for building out code, for building out features, and for letting ChatGPT understand the exact structure of this application. We have access to a unit test directory. Again, there's nothing going on in here other than that it is actually working. We've got linting happening in the rubycop file, and we're using guard to run the linter and the unit tests every time a file changes. That's the application structure, but now let's move on to what we want to build. Basically, I create YouTube videos. And the way I do it is I use eCamm Live, where I'm recording videos in individual segments. The videos, as they're being recorded, are saved into a date timestamp file in one folder. Now, this is the same sort of process that would go on with OBS and other software like Camtasia. As a recording is saved into eCamm or OBS, I need it to be moved to the current project that I'm working on. Now that project might be a long-form YouTube video or it might be an episode, but under that there will be a recordings folder. When recordings are made by eCamm Live and other sorts of software, they usually use a date-time format, and I need that to be renamed to a label that makes sense to me. Now, ideally, I want a chapter number like 01 or 02. I want a part or segment ID like A, B, and C. And then I want to know what that chapter is about. So the word introduction or the word outro might be what I label it with. The last thing that can sometimes be useful is adding keywords to inform automation workflows later on what I want to do with this content, such as send it to the teleprompter. Now let's have a look at my workflow, and currently I'm doing that manually, and this software will solve that particular problem. But it looks like this. I need the ability to change focus to either a video for long form content or an episode for a podcast, or maybe in the future ideas like YouTube Shorts. I also need to be able to switch focus pretty quickly. Additionally, when I'm creating a video, I'm usually thinking in terms of chapters. So chapter 1 for the introduction, whatever the last chapter is would be the outro or the end card if it was on YouTube. This application is simple in principle in that it's just waiting for the next recording and moving it into one of the video project folders. The way that looks is that a file watcher is just looking at any file that comes in and then moves it into the recordings or episodes folder. From there, I have two very simple actions that I usually take. Either I want to label it appropriately with a chapter sequence, part ID, chapter title, and potentially keywords, or I want to put it in the trash can because it was a bad take. Lastly, there are a bunch of actions that are secondary to the main problem, and they are things like creating a new project or switching to an existing project. I need to be able to move videos up and down the sequence or up and down the chapter. I need to go to the next chapter or rename chapters, and things like doing a transcription or automatically generating B-roll, or sending the transcription to ChatGPT to get a better quality script so that I can redo that particular segment are the sorts of things that I want this application to solve. We've just looked at the process and the workflow for FliVideo. Now let's have a look at the features that we want to build into the application. By going down to the documentation section, clicking on feature list. It was all built using ChatGPT. Essentially, it's just a list of headings and really brief descriptions. Later on, I'm going to use a GPT to convert these into a component meta language, which will produce very accurate code from each of these simple features. Now I have about 20 features that I'm going to develop for this application, and they're across a bunch of different categories. So the first one we work with is state management. And I'll have to develop code to manage the global configuration for the application. Also, each video project that I create are going to need their own set of configuration for the files and folders. When I run the application, I want to run it from the command line interface. I'll have a CLI set of commands for the projects that I'm working on. There'll be one other piece of code that I need to have running, and that's a file watcher, because essentially this is moving files from eCamm Live into various folders on my computer. The next set of features that I need in the application will revolve around what this application is meant to do, and that's video asset management. I should be able to create a project or add a new episode to an existing project. I should be able to switch focus at any time, either between episodes or to completely different videos if I want to do a recording in the moment. I need to have the capability to calculate episode paths and project paths, and a recording namer. This is where a lot of the usefulness of this application is in labeling recordings correctly. And lastly, I might want to take individual recordings and do stuff around chapters. The next set of useful features is around file management. I have the area called bad takes and one called miscellaneous. This is basically moving the eCamm file over to the project or just opening it up in Finder. I'm running on a Mac and I want to open up and have a look at those files directly. With the bad takes, it's really about, do I put it into the trash? Do I undo it from the trash? Or do I clean up the trash? A couple of useful workflows for me would be text-to-speech, where I use Whisper AI to transcribe all my videos, and the other one is creating chapter videos. I do most of my video editing in Descript or DaVinci Resolve, but when I'm developing a video and it's in various parts, I often just want to watch a single chapter at a time, and that's what this function will do. All the features up until now have been about managing my recordings and various projects, but the real power of this system comes in when we get to data. And what that really means is that for every video I do, I need to get a copy of all the transcripts and the project metadata. The metadata is usually concepts like the keywords that I might put into a file name. They can be used by the video editor to know what they've got to do, or they can be used by automation GPTs. And that's what we go into next. My plan is to use the transcript and keyword data that I've generated out of the videos and pump that into various GPTs. And the ones that make sense for me is to create lower thirds that only do highlight words rather than every word in the video. The ability to do DALL-E 3 prompts. So if I just want to automate B-roll creation, I should be able to use it with, say, images from DALL-E 3, or in the future, other text to video generation models. Whenever I do an introduction or sometimes the outro to a video, I sometimes want to take what I've done as a pre-recording and make it better using ChatGPT, and that'll be done using the transcript to teleprompter GPT, and of course making things like YouTube titles, YouTube descriptions is a really easy thing to do if you've got your transcribed text. And lastly, some sort of GPT that can build chapter headings and put them into the YouTube description. Let's now look at a GPT programming language called Clueless, which stands for the clue is to do less. Clueless is a domain-specific language designed for generating code using ChatGPT. Using various GPT agents, the Clueless component creator allows me to define code in a language agnostic way using concepts like principles and patterns and contracts, but not the actual code implementation. The clue components can then be passed through to the pair programmer, which will produce code in Ruby or Python or whatever language you want to use that follows OO principles. In the next video, I'll go over the pair programmer and the component creator GPTs in detail. Let's have a look at a couple of them and see how they also match to these features that we've been developing. I've created a node here called Clue for the Clueless components, which I've already put into the code base. Clueless stands for the clue is to do less, or as a developer who doesn't necessarily know how to code in a certain language, you can be clueless and still productive. If we take one of the features that we developed, it was called Create Project, and that's basically set up a new video project. Or if we take another one like Bad Takes and we look at the trash component, which is the idea of taking a video that I've recorded but I don't want to keep and just storing it in a trash can temporarily, how could they both look as components? Now, I've just opened up our project that we're working on, and we're going to have a look at our first clue component. What we'll look at is Create Project, which according to this says set up a new video project for standalone YouTube or podcast videos. Now I'm just going to open up this clues folder, and I've created a whole lot of component definitions already, and I used ChatGPT to build them and then I customized them afterwards. So if we look at the create project definition, we can see that we've got this component called create project, and the idea is that it's going to produce some sort of class or collection of classes that do the thing of creating a project. The description has come through, set up a new video project for a standalone YouTube video or podcast, and what design pattern would I like to produce the code in? In this case, I want to use the command pattern. Now for this component, I've then given a bunch of comments around what the code is meant to do. It allows for the creation of a new project. specifying it as either YouTube video or podcast episode. It talks about what happens when you've got a video versus a podcast, and it talks about storing project specific settings. So we're setting up a goal for this class, which we would normally write as just a natural language expression in ChatGPT. But what then makes this useful is that we start developing structure. So we said we need some sort of enumeration type here. The project type should be video or podcast. And we've got a method that we want. We've called it run. Now, if it was a regular command pattern, it would probably be called execute, but I like using the term run. And so my assumption when code gets generated in JavaScript or Ruby is that I'll get a class called create project. It'll follow the command pattern. It will have a method called run, and it will accept some parameters: project type, project code, channel code, and project name. And ultimately, whatever code gets generated will follow the instructions that I've listed here. And to help define this and make it more solid, I also give a couple of examples of how this would be run in an actual application. Now, the actual technical documentation clearly defines what each of these properties are, and this is included when you use the clueless GPTs. It does understand the technical definition or technical design document, but in here you can see that if you create a project and you ask for it to be a video, and it's for project code A20, and it's for the Appy Dave YouTube channel, and it's got a name of some video, then there's an expectation that it will create in the video projects folder all of these subfolders underneath A20 AD subvideo. So we have a configuration file, an assets folder, a chapters, recordings, and trash folder. There's also a section here for if it was a podcast project. And under a podcast project, there are no recordings because there will be additional episode folders under there. So here we see just the folder, and the configuration file would be the expected output. And all of this definition code, it becomes the prompt. It's not the way we would just say it in English, but it looks very much like a coding construct. And so the code that we get out the other end is more predictable, more consistent. Let's move on to a second component example. We'll go to bad takes and we'll look at the trash component. It's about moving suboptimal videos into a designated trash folder. This happens because a lot of the takes I do, I just don't want to keep. I make certain sorts of mistakes while talking. I don't necessarily want to delete it just yet, but I do want it in the trash can. So here we have the move to trash component. The description is a little bit simpler than the feature that we started from. It's move the suboptimal video into a trash can. It's using the command pattern. It has two concepts. It can either move a recording that's already been saved and labeled into the trash can, or it will just take the last eCamm recording, which is date and time stamped, and move it into the trash can. This definition is stating that it does need a constructor and that it should take a parent project as a reference. The idea is that it's not just looking in any old folder on the system to trash recordings, but it's doing it to a particular project. And the actual file name that we want to trash can either be passed in or left alone if we just want to do the last eCamm file. I'm just having a look at the sample of moving a video into trash. Now, if you've used ChatGPT for a while, you know that if you get really specific, it can give really good outcomes. And one of the things that's not specific about this is that we have a label called move to trash, but we have two different concepts going on inside of it. Now, it's probably going to be okay, but because this is a prompting language and you want to be quite detailed, I like to have examples that cover each scenario. We just take one of them and clone it, and I'll just rename the samples as move named video to trash, and this one will say move last eCamm video to trash. And the one that's named video will look up the project path, create a move to trash command using the project path in the constructor. Then we'll just run this specific example that says if you give it a video that you want to put into the trash can, ultimately within the project that we're talking about, there should be that file inside the trash subfolder. Now the move last eCamm one, it's basically the same go get a project, instead a command of some sort, but we run it without a parameter, and we should see that an eCamm oriented file right here is sitting within the trash can. This would be the basic outcome that we want to see this component making code to do. That concludes the second part of the video series on creating FliVideo, and it also introduces the programming language Clueless. The clue is to do less, which is a GPT meta language designed to produce consistent and repeatable code in a variety of programming languages. In the next video, let's start creating this application using Clueless components and GPTs to generate a lot of our code.